Yeah, the next question from the median bucket, it contains duplicates. So what it says is you're given an array. You are given two integers, k and t. So k is kind of a window where you have to scan for the duplicates, and t is the difference. So it's essentially not duplicates as such, but it is nearest duplicate. Like what is the value which is within the window of t. So what it says is you have to find two numbers, num of I and num of j. Okay, and the absolute difference between those two should be at most t. Okay, and these two numbers should be within the window of I and j. Okay, and their absolute difference should also be at most k. So there are two variables. Just take note of the variable. One is t and one is k. And k represents the difference, absolute difference of the indexes, whereas t represents the absolute difference between the values. Is the problem clear?
Yes.
For everyone? I hope it's clear for everyone.
Yes.
Okay. Anyone has already solved it? Or has any approach for this one?
One approach I take is like you mentioned, right? For every window, I'm searching for absolute value of t. So in case of the example one, I have the window of 3. So I scan every window and search for, is there any element within that window? The absolute value is less than or equal to t.
Okay. That's kind of a brute force approach, right? So
yes.
Taking every window and then trying to find whether there's an element which is having absolute as t, right?
Right.
Okay, any other approach? Anything else, like any other data structure we can use?
I think I could use a map. Yeah, the map is to put the Windows number to that map. If the user map and at the same time I use 2 pointer. Yeah, one pointer is iterate the whole array, and another point is point to the left start of the window. If the window size is larger than k, the map erase the number out of the window, and we will find the lower bound of the difference in that window. If it less or equal than t, that return true. Yeah, or else we will return false.
So you're saying you will take a window of size k and then create a tree map out of it?
Yeah, use 2 pointer to create the window and record each number of that window. Put the element in that window to the map. Yeah, when we iterate the array.
Then, and then how will you use Treemap? Like you suppose you have a window. Let's take let me share my screen.
In that case, like
So suppose this is the input, right?
Yeah.
and our window size is 2. So my first window will be suppose 1 and 5, right?
Yeah.
And what will I do next?
And we use a for loop to iterate the whole array. Like we use a pointer I to iterate the whole array, and we use another pointer j to
So you
point.
loop, you loop from 1, 5, 9, 1, 5, and 9, right? You loop over all the elements and find, what will you find here?
At the same time, the j pointed to the 0 index 1, and when the I minus j larger than k, we will erase the map, the element 1. That means keep the window only contains two elements. Yeah, move the window.
Got it. So your first tree map will contain elements 1 and 5, and then it will contain 5 and 9, right?
Yes.
But my question is, how will you find whether there's another number which will give you a absolute of a minus b equal to or less than equal to 2 in this case, right?
Yeah, we use a map to record the index of the element, like the M1 is equal 0, M2, M5 equals 1. We save the index of each element.
0 and 1, and this is 1 and 2, right?
Yes. And I use the low bound.
You use lower bound?
Yeah, lower bound. Numbers I minus t.
I minus t.
Yeah, that will find the lower bound of the difference between each element with the t.
This I is the index of the current element or the value?
The I is the index of the array, the pointer to iterate the whole array. The I is the pointer to pointer of the window right. Yeah, the j is a pointer to the left window, and the I point to the right window. Yeah, that I is the index, and if the lower bound is found, and the absolute value between the a of the first, the a, let me see, let the a variable equals m lower bound numbers I minus t, and if the a iterator.
But there's one question. You have I as index and t as the absolute value of absolute difference of values.
Numbers I, not only I, numbers
okay.
I.
Let's apply.
Yeah. And if the iterator is found, and the absolute between the key of the iterator and numbers I, and less than or equal than t, then we return true.
Okay, so let's assume you have a value of t equal to 3, and suppose your a of I, that what you are looking for, is suppose 4, right? Then you are trying to find whether you have 4 minus 3 equal to 1, which is equal to 1 in your already right. That's
yes.
Right?
Yeah.
Now suppose your a of I is minus 4.
Then that means we find the one that that one is maps iterator. The maps iterator has 2 elements. The first element is the key. The key is the value of the element, and the second is the index. So we can use that iterator to get the value of the element, and minus the the numbers the AI. That means we find the difference between two elements. If this if the difference is less or equal than t, that means we can return the true.
Just one thing, I'm not sure what lower bound does in C++. Does it give the value which is the greater value which is lowest, or the lower value which is highest?
Yeah, it's equal or larger than the target value.
Equal or larger. Okay. So let's assume you're trying to find this one, a of I, suppose equal to 4 plus 4, right? Now you are trying to find whether 1 or 5 is there, right?
Yes.
And sorry, one value, and then you have elements as 5 and 10, right?
Yeah. You mean AI is 4 and the target value is 3?
3.
Yeah. And the difference of AI minus t is 1. Yeah.
Right. And then suppose in your tree map you have values 5 and 10, and the lower bound will give this value, right?
Yeah.
Right. And suppose, and then you get 5, then 5 minus 3 is equal to 2, right? Now let's assume we have 15 and 20. What will happen then? We'll get 15 minus 3, which is 12, right? Which is not within the range.
Yeah, if it's not in the range, we can go to the next window. And once we find the difference is less or equal than t, we will reach.
But then we are missing one point. So we have to look at the absolute value. So for absolute values, it can come from a positive side or a negative side. So if we consider mod of a minus b equal to, or let's say a minus b equal to c, then we have actually two equations here, not just one. So we have a minus b can be equal to c, or b minus a can be equal to c, right? Because mod will convert both of them into a single value. So we cannot just look at one side, a minus b. We'll have to look at the other side also.
We just put the difference between the example 15 minus 3 equals 12. We put the absolute value of the difference between two elements, and we can solve this situation.
So suppose your array has these two elements, minus 2 and plus 15.
Yeah.
Right? And again, the same things. We have 4, then we have 3 as t, current element is 4. So this is your original state. And now the elements in the tree are these two. Right? You'll take 4 minus 3 is 1. And then your floor or the lower bound will be 15, which is not within the bounds, right? But actually you do have one element which is minus 2. Okay.
Yeah, the lower bound will find the element larger or equal than than your target number. So if you are looking for the lower bound of 1, the iterator will return the next element to minus 2, because minus 2 is less than 1, and the iterator will point to the next one, like in your example is 15 here.
Okay, but what I'm saying is, according to your logic, you will see to the 15, and then 15 will not give you that target of 3, right? So you will move ahead and go, move your window to the next element, right?
Yeah.
And then you're missing one of the element which can give you a target value, minus 2.
Yeah, next window means we move to the 5, 9 window.
Yeah, let's assume these are the 3 numbers, minus 2, 15, and 10, right?
Here? Yeah.
And if you are looking for AI equal to 4 with target equal to 3, right? Or target equal to 6. Let's say it's 6. We can make it bigger. Now, your target, you're looking for 4. 6 minus 2 is 2, right?
6 minus 2, 4. Yeah. 6 minus 4 equals 2.
6 minus 4 is 2. You're looking for 2. And then what you'll get from lower bound is 15.
Yeah.
Right? And 15 minus 4 is not within the bounds of our requirement. It is greater than 6. Right? But there is another element like minus 2. If we do minus 2 minus 4, it will give us the range which is 6. Right? We'll miss this element. We just have to find whether there is one more pair or not. And if you move ahead with this one, your window will change and you lose this number forever.
Yeah. Yeah, maybe I think.
Yeah, so I'll just clear it. So your approach was right, but there's only just one caveat. So coming back to the original equation, mod of A minus B equal to C, right? This is the original equation. Now let's assume this is our T. This is our target. This is our num of I, or the known number. And this is what we have to find out from, like in your problem, it's from the Treemap. Right? This is what we have to find in Treemap. Now coming to, this can be actually converted into two equations, like A minus B equal to C and B minus A equal to C. Right? Because of the mod, both of the, because of the mod, they will both convert to C. Does it make sense? And let me write it into the equation of num minus search element equal to C, or num, search element minus num equal to C, which will give us what we have to search for is, one is num minus C, and the other element to search for is C plus num. Right? There are two values. So let me give you an example. Like suppose I have A equal to 3, target equal to 2. So to get A minus T, or let me A minus B equal to some value T, which is here 2, I can have two types of values, like 3 minus 1 will give me a mod value of 2, right? Or I can do 3 minus, or rather, let me do it this way. 5 minus 3 is also equal to 2. Can we now relate this into something like this? So any value between this and this, if you take any value between these two, you will get this equation satisfied. Let's say 2, right? 3 minus 2 mod is equal to 1. Let's say 4. 3 minus 4 is equal to, if you do a mod, it will still be 1. And it is less than 2. So these will give you the two bounds, these two numbers, 5 and 1, where you need to find any number such that the equation is satisfied. Does it make sense? Or should I take another example?
I can add a like non-technical way to look at it. What we are trying to do, maybe that will help to think in that direction. So the first approach, which we were given, that we had a window and we were trying to go and look at each elements to make a decision. And that was a workable solution, but not good enough. So now we are trying to, get better. For example, suppose you are given height of 10 guys in a sorted order, like, you know, from minimum to maximum. And there is a new candidate. You want to pair that candidate with a guy so that, like, you know, their height difference is minimum. So they will look less odd if they go outside, for example. I'm just making up an example. So what will you do? You know, it's sorted. You will try to find a person of almost equal height or equal height. Suppose you found that point in when they are standing, only the person on the left or right is going to make decision for you, because persons on the extreme left or the extreme right, they are not going to be paired up. Does that make sense? Because if you just, like, you know, find something in middle, like, you know, something which has just smaller than it or equal to it, if possible, then it's fine, or just greater than this, you will find the absolute height difference between those guys and you will pair up the candidate. And that is what exactly we are doing it here. Like, that's a non-technical way to look at it. Does that make sense?
So in terms of what Roger is saying, we are just here trying to find out if we don't take in terms of the height. So this guy has a height of suppose 3 feet, and we are trying to find other folks in the array or team such that the height difference between those two will just be at max 2. So if I have my height as 3 and there's a guy who's, you know, a height 1, which is just lesser than me, I'll still be able to achieve this. And if there's a high person who's, you know, taller than me, I'll still be able to achieve this. And anyone who falls in between these two numbers, I'll still be able to satisfy the equation, because these are my two extremes. If I go anything below that, my number will start becoming greater than 2. And if I go anything greater than this one, my number will again start going up, right? So it's like an equation where you have to find the two bounds after which your numbers increase. And these numbers will, you know, not be in your data plot range.
I think everyone understands already, I guess. That's why there is no question, I think. Maybe.
Either it is clearly understood or it is clearly not understood.
Yeah,
Guys, if we have any questions.
Yeah, please ask questions if it is not clear, or if it is clear, then good. We'll move.
Yeah, looks good.
Okay, let's move on to the next one then.